Now, we'd like to open up to questions, even we're running right on time almost. So I'd just like to open up to a panel session if we can. Can we put the speakers up on? Great. There you all are. Welcome back. What's the best way to do this? Perhaps some questions from Slido first. Anything come through?
Yes, there were quite a few. So the first question from John Pye was for Kristen. Can you give any numbers around what carbon capture, utilisation and storage might add to cement costs, and whether that changes cement's competitive position, e.g. against engineering wood products?
Can you please repeat the question? I was busy finding where I should unmute, so please repeat.
Can you give any numbers around what carbon capture, utilisation and storage might add to cement costs, and whether that changes cement's competitive position, e.g. versus engineered wood products?
First part, I can say yes, it adds a lot of costs. On my head, if it's up to from 50 to 80, 90% additional cost of clinker, which you then have to dilute as much as possible to reduce the use of it also. Compared to wood products, I have no idea because I don't know anything about engineered wood products, unfortunately.
Thanks very much. Yes, I think we're well aware. Does anyone else have a comment about that from the panel? About carbon capture and storage costs? Warren or Felicity?
All I can say is here in Australia, it's not even on the horizon at this stage.
Okay, thank you. Another one.
So still on the topic of clinker, from Daniel Luden, what scope is there for the production of clinker from non-carbonate sources of calcium?
Karen, perhaps you might like to comment.
Yeah, I think this is a hugely important question, and I think we have to realize that the amount of uncarbonated calcium on a world scale is just very, very low. I haven't managed to find an exact figure for it, but I mean, you know, anything you can estimate really shows that it's very, very low. So while, of course, if we do have uncarbonated sources, like as may be the case from demolition waste, that's a good source of uncarbonated calcium. And the fines from demolished concrete can be very well taken back to a cement plant, and they can decrease CO2 emissions. So this is a technology that's been looked at, but I think it's going to remain a comparatively small amount, especially in those countries where the cement demand is going up. These are kind of solutions that really can work in developed countries, but as we've seen, these are really a very small minority of CO2 emissions from cement.
Karen, perhaps I'll just have a quick question in there. Do you have any idea of concentrated solar thermal that could be used for calcining these clays, given that the temperature's reasonably low?
Sorry, what was the question?
Calcining clays with a lower temperature, I think you said 700 to 800 degrees.
Yeah.
And the prospects of doing that in countries, third world type countries, developing countries?
Oh, I think this is very easily implementable. I mean, you can use existing cement production technology, and you know, we have a plant being built in the Ivory Coast, for example. Angola is looking to switch over to production of this. So I think this is very, very easily accessible technology. Because you have lower temperatures and no CO2 loss from decarbonation, then the kind of CO2 emissions from calcining clay are around 200, 250 kilos per ton, in contrast to clinker, which is more like 850. So they're about a quarter of the emissions from clinker, but very easy to do, you know, almost anywhere in the world.
Thanks, Karen. Anything else from Slido at this point?
So we've got two questions about kaolin. So from Ray Chatfield, Kaolin is often found at the bottom of bauxite mines, particularly in WA. Is there a synergy between bauxite mining and kaolin-based cements?
Well, yeah, I mean, anywhere you have a current exploitation and then you have kaolin at the bottom, that's a very good place to find it, because you don't have to open up new quarrying sites, which of course is not what we want. So, I mean, this is my point, that, you know, you have a superabundance of these kind of materials, and often as waste. Another place you get waste is from aggregate washing. You know, often aggregates are washed to remove the fine material, and then you have huge amounts of kaolin-rich fines, which again can be reused in the cement plant. So all of these kind of synergies are exactly what we should be looking at to reduce our kind of resource depletion.
Perhaps I'll throw a couple of questions to our cement making people. Last time we ran this forum, we came up with three approaches to lowering carbon in the process. We looked at alternative fuels. I'd be interested from both of you to know what we've done to do something more about that particular initiative. Looked at concentrated solar thermal for calcination. We looked at carbon capture and storage. I think we've heard a bit about that, and alternative raw materials. Do you want to comment on where those particular technologies have gone in the last 18 months? Felicity, you look like...
Yeah, so perhaps I can talk on alternate fuels first. I can only really talk from what I know of the broader industry in Australia and the Adelaide-Brighton work, but we have done significant trials over the last 18 months to increase our usage. That's going through the environmental agencies at the moment, but looks like it'll be successful. So we should be increasing our use from about 25-26% substitution to 45%. We will continue down that path with some other fuels probably that we're investigating at the moment over the next few years. Over the next probably 3 to 5 years, we're anticipating that will increase further. We're in the early stages of investigating the same for our lime kilns. In terms of alternate raw materials in clinker manufacture, looking to pre-calcined, potentially waste materials from other industries and utilising those in our clinker kilns to reduce our CO2 footprint for clinker is something that we do progressively, and we have been doing over the previous 5 or 6 years. We're in the midst of a trial with the Steelworks at the moment to further that initiative. So that's on the clinker side. I don't know if you'd like to comment more broadly on the industry, Warren, but from what I'm aware of, other cement kilns around the country have initiated some C&I, C&D fuel use in the last 2 years, and they're sitting at around maybe a 10 or a 15% substitution from what I'm aware. And there are clinker kilns in Australia that are using reasonably high substitutions elsewhere, but in those cases using things like solvents and other liquid fuels, and not necessarily low carbon fuels like a high biomass percentage alternate fuel.
Just putting in C&I as commercial and industrial waste, is that right? And yep. C&D yep. is construction demolition.
Demolition waste, yeah. So they tend to be high biomass waste fuels, whereas a lot of other alternate fuels are not necessarily low carbon, particularly when compared to natural gas. So that's it's a I guess that what I referred to earlier in my discussion around alternate fuels in the cement industry were really in their infancy about using waste-derived fuels, not necessarily about reducing greenhouse gas emissions.
What's your experience, Warren?
The other two manufacturers both have, as Felicity said, some experience with alternate fuels. Boral of Berrima is using some waste materials, and there's the geocycle facility used by Cement Australia. There's really two main issues. One is the availability of suitable materials, and the other one is the distance of haulage, and so the transportation costs of some of these materials. I suppose there's a third one, which is the long length of time that it takes for environmental agencies, which differ from state to state, for them to give their allowance, if you like, to use some of these fuels. I think the process at Berrima was about 2 or 3 years to just get it to a trial stage. So all three manufacturers are using materials, various forms of AFMs, and really it's around availability of those materials that are reasonably close, I would say.
If I just throw to you, Christian, the use of hydrogen and oxygen in terms of capture, may or may not be in that, but also of carbon dioxide as a fuel in carbon monoxide. We heard a little bit about that in some of the previous speakers today. Have you got much experience about that through your capture and storage side?
Yes, not for cement, perhaps, when we talk about hydrogen. Not sure really where you would use it. You would just dilute the CO2 by burning hydrogen as a fuel. But there's a lot of activity ongoing in Europe in hydrogen as a fuel to replace natural gas or to be burnt in fuel cells, ship engines, where you would then reform natural gas or use electrolysis to produce hydrogen, preferably both, to balance renewable energy, but also have a steady state production for reforming, and then store the CO2 from that part that's reformed. And there's a lot of work. It's not really happening yet that you're doing it and reforming the methane and storing the CO2, but there are lots of projects ongoing, plans, and hydrogen is, I think it's going to come in Europe.
Is there an opportunity?
But not in cement, I don't think so.
Sorry, is there an opportunity to put hydrogen into a calciner vessel? Sorry, I'm talking now.
Answer that. Maybe somebody else can answer that.
Oh.
I come more from the CO2 capture side than from the calcination side and the cement side, I would say.
That's all right. Put that one to the cement producers. What do you think, Felicity?
If I could also make a point about the Australian experience, not answering your question, sorry, Ros, but the other point is we don't have a price on carbon. And so being able to use some of these materials in a substitutional sense really is the economics really have to stack up. And a lot of that is about alternate disposal means rather than substitution of carbon or CO2.
Thanks.
Yeah.
Felicity, do you have anything that you can add about hydrogen?
Hydrogen? I think the jury's still out a little bit on whether hydrogen can be used. Like you say, in a calciner vessel where it's just supplying heat, it's interesting. I think the oxygen that's potentially produced at the same time, depending on how the hydrogen is produced, is interesting for the industry. A lot of the plants that I'm familiar with are operating at capacity. It's unlikely that many more clinker plants will be built, so improving their capacity is, and fuel efficiency is obviously, electricity efficiency with fan use and air use through the system is always a target of clinker kilns, particularly in this country, as far as I'm aware. So, yeah, hydrogen maybe not, but oxygen enrichment maybe.
Okay, well, perhaps if there's not, is there anything else from Slido that we
There's a
should
few
throw
more
in?
questions.
Oh, okay.
So I've just put a couple together from John Pye. It's a question for Karen. Could you clarify whether kaolin-based cements result in high alkalinity, affecting groundwater, other safety issues, corrosion of rebar? Does LC3 have this issue? And related, from David Cochrane, what is the potential and barriers to using more alkaline bauxite residues in cement manufacture?
Okay, so I mean, taking the first one first, if we put these calcined clays in the cement, we have a slight lowering of the alkalinity. So we still have enough alkalinity to protect reinforcement bars, but this slight lowering is actually extremely beneficial in terms of reducing susceptibility to alkali-silica reaction. And we think it also plays a role in the extremely good resistance to chloride penetration we have. So there I can really reassure you that there's no risk of contaminating groundwater, just the opposite. Now, of course, this problem of alkalinity is the problem of using bauxite residues like red mud. So clearly that is a huge problem from an environmental perspective, getting rid of these pile-ups of red mud. And you can use this as a substitute raw material, but only in very, very small amounts because of this high content of alkali. So I think what the real breakthrough we need there is some better technology for reducing the alkali levels in these wastes and putting the alkali to use elsewhere. But I can't really say more than that.
Thanks, Karen. Gus.
Yes, I would like to add my thanks to the speakers. It's been a really useful and positive discussion. I would really appreciate if the panel could provide their complementary perspectives on some of the timelines that they see for best practice decarbonising. I was really encouraged by Karen's presentation about the potential extent to which some of the kaolins could be blended. But there's a number of different perspectives here, and it would be great to see where the different panellists could give some comment on what they see some of the potential, best practice timelines for the sector. Maybe, obviously, different regions have got different elements in that. But if you could give your comments on that question, please, that would be helpful.
Perhaps we'll start with Christian on carbon capture and storage.
Yeah, best practice timelines. I'm not sure. If we start with the Norwegian project, if we have the investment decision this year, there will be a capture, transport and storage project with cement by the end of 2023 or early 2024. But also to connect a little bit what we'd be talking about now, Warren talked about this, the need for concrete in the future. That's a good material, and with the increasing urbanization, yes. And also, Karen mentioned this briefly, that in the future we may need to pump CO2 from the atmosphere. We need to go CO2 negative if we look at the IPCC scenarios. So cement and using solid residual fuels or biofuels, we also have other advantages from actually using these fuels and doing the CO2 capture. Even if you use less clinker then afterwards, it's a way of actually going CO2 negative if you have a high degree of CO2 capture and biogenic fuels in there. So that's the timeline for that, I don't know, but the plant in Norway usually uses very little fossil fuels already. So it's part of it.
Thanks.
Around 2024 to get back.
Karen, what do you see for the future?
Well, I
Caleb?
mean, this is the point I was trying to make. We really have to go fast here. And, this is all very good having this project in Norway. That's great. But Norway is a very small population. And if we look at the whole of Europe, it's not going to be practical to put in place the infrastructure to pipe the CO2 offshore. So this is why I really think we have to implement these accessible solutions. And this was very much the study we made in our European report. What can be implemented now? Because everybody's always saying we've got to change codes and standards, but there's an awful lot we can do now. And, I think just things like implementing what we already know in concrete technology. So having good aggregate gradings, which can, as I tried to illustrate, reduce the cement use by 50% or even more. This is accessible today. And often the obstacles that people cite for not doing this are kind of really pathetic when you look at the climate challenge we're facing. People say to us, oh, we haven't got room to install 3 aggregate silos on the job site. And so we're going to use twice as much concrete as we need to. I think this is inexcusable in this day and age. And we really have to emphasize to people that, savings we can implement quickly, we have to do immediately. And we have to find mechanisms in terms of carbon pricing or whatever to really push people to do this.
Thanks, Karen. I think you sort of summed that up in changing construction practices, and whatever gets done is going to involve something in that line. Warren, do you think future?
Thanks, Ros. I'd just like to start off with a fun fact for Karen. She said that the possible savings of CO2 through the implementation of LC3, I think, was about 400 million tonnes annually. That was the calculated CO2 emissions from the bushfires in Australia in the last 6 months. So even more reason to introduce technologies like this. My issue, and again, Karen touched on it, is codes and standards. Here in Australia especially, the influence of state government authorities on those specifications around materials are huge. It even gets down to approving mixed designs for concrete. So there has to be some sort of leadership shown through governments, through their representatives in standards regimes to be able to achieve any of these changes that we're talking about. And from an Australian context, we've been trying to do something small with the Australian standard, and it's taken 10 years and not achieved it. So I would hope that with the community change that I talked about, that we can actually see that translated into a more flexible and perhaps innovative codes and standards and specifications. Thanks, Ros.
Thanks, Warren. Felicity, the last word. I think we're up to the last word.
Yeah. Only probably to add to what Warren has said, in that it's hard to comment on how long some of the technology might take, but ability to implement it quickly within industry, which goes to all the things Warren just mentioned, but also some things that were mentioned earlier in the discussion around the retrofitability of technology. In most places in Europe, certainly within Australia, our ability to retrofit any technologies that reduce carbon is really important, because I don't foresee a position where we'll be building a number of new clinker plants. It's really about making sure we can get technology through into our industry quickly, and making those pathways open.
Great, thanks very much. Does that sort of draw to a close this session? Thanks, Gus. All right, thank you very much, everyone. Perhaps we can thank our speakers.